Hello, you welcome back to another exciting edition on Maths with Chris. In today's lesson, we are looking at distances along great circle. That distances along meridian. That's another name for it. How do you find the distance between two places that are on the same meridian using this example? It's very simple. Just watch me as I do my thing. The position of Abuja and Bonn to the nearest degree are 9 degree north, 7 degree east, and 51 degree north, 78 degree east, respectively. Use R is equal to 6400 km to calculate their distance apart. Before you can solve this question, you need to first draw the earth and locate the places. Get your angular distance and angular difference, because we've done angular difference in this lesson in our previous classes on this channel. So you can check how do you get angular differences between two places. So let's use this example. If you watch it clearly, you can still get the angular differences between these places without much ado. So let's look at this example. So I'll first draw the earth. So let's assume this is the shape of the earth. Oh, let me draw it on this side. Let me draw it on this side so that I can see it clearly. Now, if this is the earth, this is the east and west pole, the north and south poles, and the equator. Then let's locate the places. Abuja is 9 degree north, 7 degree east. 9 degree north. North is the upper part. So you have 9 degree north. This is 9 degree north, 7 degree east. The eastern side is here. So this is the 7 degree east. Where the two lines they meet, latitude and longitude, where they meet here, that's Abuja. Let's use A. Then Bonn, 51 degree north, 7 degree east. 51 degree is supposed to be above. Let me redraw this one. 51 degree is supposed to be above 9 degree. So let's say this is the 9 degree. So this is our 9 degree now. This is the 9 degree, Abuja. And 51 degree will be the upper part now. This is the 51 degree north, which is Bonn, Germany. It will be this place. It's 51 degree north, 7 degree east. So it's still on this line. That's why this is the Bonn now. Now, since the two places they fall on this meridian, on this great circle, I will trace the distance between the two of them to the center of the earth, because they fall on this great circle. So if I trace it to the center of the earth, this is what I'm going to have. Okay, is what I'm going to have. Now, from this place, I'm going to note from this place to this place now is my 9 degree. While from this place to this place is my 51 degree. So how will I get the angle between the two places? Let's assume I want to bring out this sector of a circle. This sector now. This is what I'm going to have, which is this and this now. You have this line for the A, and this line for the B. Then you have this arc joining them. This is my A, this is my B. From here to this place, that's the 9 degree, which is from here to here. Then from this place, from here to here, that's the 9 degree. While from this place to this place is the 51 degree. That's 51 degree. So the angle between the two places now, this angle here, is our angular difference. And how do I get the angular difference? Since everything from here to here is 51, and from here to here is 9, this one should be 51 minus 9 because this is outside the sector. So my angular difference theta should be equal to 51 minus 9. So in that case, if I have 51 minus 9, that will give me 42 degrees. So the angle between the places now is 42 degrees. Then to get the distance between the two places, I need this place now. Distance between the two places. And recall the formula for distance between two places, the distance between length of an arc, distance is given by theta over 360 times 2 pi r. Where this r now is the radius of the earth, given to us as 6400 kilometers. And this theta is our angular difference. That's why to calculate angular difference is very important. You must know how to get the angular difference before you can do well in latitude and longitude. So you can check our previous lesson on angular differences. We did 8 good examples so that you can understand angular differences properly. Because it's very important for you to know angular differences before you can do well in latitude and longitude. So let's continue. Then our distance D will be equal to 42 over 360 times 2 times pi is a constant also, which is 3.142 times 6400. If I continue with this, my distance, so now if I multiply this, I will have distance, let me solve it here, should now be equal to, or let me continue it here. So my distance D will now be equal to, if I multiply everything now, 42 times 2 times 3.142 times 6400 divided by 360. So that will give me 1692 kilometer. You have 1692 kilometer. So this is how you find distance between two places on the Earth's surface, and the places must fall on the great circle. And this is how you set the diagram out. This is how to get the angular difference, and this is the formula for calculating it. And this is how you are going to arrive at your answer. More examples are still coming because this topic is very important in mathematics.